Hello, today's lesson is part of the Kinetics, Equilibrium, and Thermodynamics unit. We'll be focusing on Part 1, Kinetics. By definition, that's the study of how a reaction proceeds. Have you or someone you know ever tried to light a match and it didn't work? Happens to me all the time in the lab. But why? It has to do with the collision theory. You learned in the last video that a reaction needs two components for it to work. The particles need to collide with enough energy. That's called the activation energy. And the particles also need to collide with the proper orientation. So when you think about your experience of lighting a match and it not working, sometimes you need to press down harder. That would be supplying more energy. Your particles didn't have enough the first time. Other times, it may require you flipping over the match. For some reason, the orientation of the particles the first time weren't sufficient or properly aligned, but by flipping the match over, now they are. In any event, no matter what our chemical reaction is, there are four factors that can affect the rate of a chemical reaction. They are temperature, concentration, surface area, and catalysts or inhibitors. Let's try to explain how these four factors can affect the rate of a chemical reaction by explaining it in terms of the collision theory. So why is it that these four factors can affect the rate of a chemical reaction? Well, we have to remember the collision theory. The particles need enough energy and the proper orientation for them to work. So let's look at temperature. How is it that temperature can affect the rate of a chemical reaction? And remember that rate means speed up or slow down. Well, temperature is a measure of the average kinetic energy of the particles. Kinetic energy is measuring the energy of motion. So if I know that my particles need enough energy, by changing the temperature, I can speed it up or slow it down. In other words, a high temperature will have an increased rate. And that's because the particles have more energy. Conversely, if I decrease the temperature, I'm now going to decrease the rate of my reaction. The particles are now going to move slower. In other words, the particles have less energy, so the reaction happens slower. That's usually the easiest factor for students to explain because it hits directly upon one of the factors of the collision theory, the energy component. The remaining three, concentration, surface area, and catalysts or inhibitors, have nothing to do with energy, only temperature does. That means these other factors must have something to do with the proper orientation of the particles. Well, concentration, if you remember, is the measure of how many particles are dissolved in your solution. Usually it's in terms of molarity. How does having more or less particles give me a proper orientation? Well, it's not as directly related as the temperature was to the energy, but rather the idea behind the concentration as well as surface area and catalysts or inhibitors is that it has to do with probability. If I have a high concentration, I have a lot of particles, so therefore the probability of those number of particles colliding with the proper orientation increases. Conversely, if I have a lower concentration, I now have a less probable occurrence of those particles colliding with the proper orientation. Therefore, the rate of the reaction goes down. So let's try to put that into words. An increase in concentration results in an increased rate because more particles means more chances of them colliding properly. And that means colliding with the proper orientation. Conversely, if you decrease the concentration, you're going to decrease the rate. It's going to slow down. And again, because you have fewer particles, which means that you have fewer chances of them colliding with the proper orientation. Our third factor, surface area. Linking it up with the collision theory, surface area doesn't have to do with the energy, but rather it has to do with the collisions and their proper orientation. Just like concentration, the greater the surface area, which remember, that means we have the smaller pieces. Is going to have an increased rate. Increased reaction rate, again, because you have more chances, it's more probable, of the particles colliding with the proper orientation. The smaller your surface area, that happens when we have large pieces, results in a decreased reaction rate. And again, it has to do with the chances, because we now have less chances of the particles colliding with the proper orientation. Finally, for our last factor, catalysts or inhibitors. The reason why we have two vocabulary words for this one factor is because they do the opposite of each other. By definition, a catalyst will speeds up the rate of reaction. I'm going to call it the reaction rate. And by definition, an inhibitor slows down the reaction rate. And the reason why these chemicals are able to influence the rate of a reaction is because they are not actually part of the reaction. They are not actually part of the reaction. They are not reactants, nor are they products. What they are chemicals that manipulate the activation energy. They are chemicals that manipulate the activation energy. And activation energy, if you've forgotten, is the minimum amount of energy needed for the chemical reaction to take place. The catalyst is able to speed the reaction rate up because they lower the activation energy, which is abbreviated EA. Let's add that in as our notes, in case you forgot from the last video. An inhibitor slows down the reaction rate because they increase the activation energy. We will revisit this concept of catalysts and inhibitors in part 2 of our lesson, but we're going to conclude our lecture today by asking you to please shift and watch a video about the reaction rates lab, where you're going to be gathering some data and you'll get a chance to see a few of these factors at work on how they go about manipulating chemical reactions and their rate.